What's up guys, Shawnthebro here, and in today's episode of the Super Smash Brothers and Platform Fighter tutorial series, we're going to be going over how we can add victory poses and defeat poses in our game. Go and play a match. And now the character that is named STB in the bottom left, the green color there, we're going to go and defeat at least one character in this standard mode, which is our timed mode where we track score. Going to damage my opponent a little bit, and then I'm going to knock them off the stage. Here they come, they're back in their respawn platform, and at this point STB is in the lead. They are the current winner of this match. We have to wait for time to run out up here at the top, so I'm going to skip ahead, and you can see we are nearing the end of this round right here. So once the timer hits 0, we are going to see all the characters do their victory or defeat poses. So I know it happened all at once, but STB jumped in the air, did a little fist pump, and all the other characters kind of shook their heads and are downtrodden because they're sad that they lost the match. Now in the future, we will bring them to a different area and have them really displaying their animations. But this is a nice little touch at the end of the round when time runs out to kind of show who won and who lost. So if you'd like to get caught up in the series and check out everything we've done, so you can see our character selection screen, our stage selection, all that good stuff, you can click this link in the top right corner right here to check out the entire playlist of the Super Smash Brothers and Platform Fighter tutorial series. Alternatively, if you don't care about that and you just care about the end results, the victory and the defeat poses, I'll link you to this episode right here, which is where we set up the timer in the standard mode that we're using today to actually determine the winner of the game. And with that out of the way, we can go ahead and get started. So this is a code and blueprint tutorial series. Almost everything is going to be in the code today. We're just going to do a little bit in the blueprint for the animation. So I'm going to go to Visual Studio, and the first thing I want to go to is SSB template character, or essentially my base character, and we're going to go to the .h file. SSB template character.h is our standard character, and in here we have things like our character state. This determines what the character is currently doing, from idle to moving, running, jumping, even if they're dead or respawning. However, I've added two new values in this enum today, E_victory and E_defeat. So E_victory, of course, is if you win the match, whereas E_defeat is if you lose the match. So victory and defeat, you can call them whatever you want, but this is what I'm calling mine. This U_meta display name equals is what's going to show up in the blueprint. For E_victory, I'm just using victory, and for E_defeat, I'm just using defeat. The next thing we want to go to is our SSB template game mode.cpp. And in the game mode.cpp, we have a function called determine winner that we set up in the previous episode. We are going to edit this today, but I also want to actually show you something I should have showed you in the last episode. And that is where to call this function. Now, we actually mentioned this in the previous episode, but I never really showed you. So I'm going to scroll down to my tick function. In here, we were checking to see if we could get the game instance ref, and if we could, we were checking the match type to see if it was the standard type. That is our timed mode that we were playing earlier in this episode. Then we were checking to see if the timer was active, and if it was, decreasing time. If the remaining time reached the minimum value, then we disable the timer, set the remaining time to be 0, and then we should call it determine winner in here, because at this point, the game mode has finished, that standard match is over. So even though I mentioned that in the previous episode, I never actually showed it, and that was my mistake. But definitely make sure you're calling determine winner if you want to perform any of the logic inside that function from the previous episode or from this episode. Now once you've done that, let's go back up to determine winner, and in the previous episode we had done everything that I have highlighted here. So in today's episode we're going to add this logic. What we did last time is determine what player won and what score they had, and then printed it to the log so that we could see and verify that it was working, and it was. But now we actually have to do something for the characters when we know that they have won, and what we're going to do is set their state to be defeat or victory. So we have a simple way to do this. We have the winner index that we set up in the function in the previous episode, and it determines the index of the player scores array that has the highest score. Now, the player scores array is set up in the same order as the regular players array in the game mode. So if I go to my game mode.h and scroll down to my players array, this is an array of all the current players. So we have SSB template character pointers, and we set that up a long time ago. The players array and the player scores array are in the same order, so the winner index will be the same for the player scores and the players array. We can know what player won by accessing the players array at the winner index. Let's start off by looping through the players array. So for integer I equals 0, I is less than players.num, and plus plus I, standard for loop. Now we want to check if I is not equal to winner index. So if I is not the winner index, this is not our winner. We want to take players at index I and set their character state to be defeat. They are not the winner. And a good way to do this is to make a function called setCharacterState. Our character state variable is currently not in a scope where we can grab it from the game mode without a getter or a setter. And if you don't know what that means, that's okay. Let's go back to our SSB template character.h and scroll down to our character state variable. So in here, this is our character state. If we scroll up, you will find a keyword like protected somewhere in here. And protected means that these variables can only be seen by this class and children of this class. There's a few exceptions to that as well, but let's just keep it simple. The game mode is not of type SSB template character, nor is it a child of it. So the game mode can't actually access this variable. You could turn the character state into a public variable by putting the public keyword right above it, and this would actually work and solve the issue. However, it is typically bad practice to just make things public for the sake of making them public. There are a lot of things that we want to keep as private or protected, and we may still want to access them in other classes. So to do this, we can make getters and setters. So a setter is a function that is public that can set variables to whatever value we pass into it, and those variables are often private or protected. So I'm going to scroll down. In my code, I already have a public scope right here, and it has my constructor in it and then two force inline macros right here, which come with the side scroller template. I've also added a new function today called setCharacterState. So void setCharacterState, and then we pass it the state that we want to set it to. So eCharacterState_state. Once you've made this in the SSB template character.h, let's go to the .cpp and scroll down to where we want to make that function. I put mine at the bottom, right above my tick function. And here is the logic. Setters and getters are usually very simple because they are just there to do one specific operation. In this case, we're setting the character state variable. We're taking the state that was passed into this function, and we're going to set character state equal to it. So character state equals underscore state. So there you go. This is what the set character state function looks like, and now we can set our character state from another class other than the character class. Let's go back to the SSB template gamemode.cpp, and now in the logic that we had here, where we were trying to set the character state to defeat, we can do that now. Players at index I, set character state, and we can pass it eCharacterState : e underscore defeat. Else, players at index I, set character state, eCharacterState : e underscore victory. Because if I is equal to the winner index, this player is the victor. Now, this will set the character state correctly, so our players or our characters will know if they won or lost the game at this point. One other thing we probably want to do is make sure that the players can't exit that victory or defeat state if we don't want them to. So let's go to the SSB template character.cpp, and let's do Control F to bring up our find. Then let's search for character state equals in the current document. When you do this, it's going to bring up everything that matches that string, and so the first one is in the constructor. The constructor runs when we spawn the character, so this isn't going to interfere with our logic after they've been set to defeat or idle. Let's hit find next and go to the next one. The next one, and really the next few, are in move right. Move right is called off of an input axis, so it basically gets called every frame, so we definitely want to block the character state from being set to moving left, moving right, or idle. if the character state is equal to victory or defeat. I already have an if statement in here that does this for a lot of our states. So we check to see if we can move. We check the character state to make sure it's not equal to blocking, stunned, taunting. And now I've added 2 more. Character state is not equal to E_victory, and character state is not equal to E_defeat. Now, after these 3, we are going to get to move right controller, and we're going to want to do the same thing in there. So we have the same if statement here. If can move, character state is not equal to blocking, and not equal to stunned, and not equal to taunting, and not equal to victory, and not equal to defeat. So make sure you add the victory and the defeat in here. Those are the most important ones because those ones fire so often from the input axis that it will quickly overwrite your victory and defeat animations. But we are going to go through the rest of this live. Let's go through the next ones, and then we get to start jump. So we don't want to be able to jump if we're in the victory and defeat animations, so we can go ahead and add them in here as well. So, and character state not equal to E character state, E_victory, and character state not equal to E character state, E_defeat. Now, an alternative to this is just to set the can mode to be false, but I do like to do both methods, the state or the boolean. In stop jump, we have this check for our states, and let's go ahead and add that character state for victory and defeat in here as well. Landed sets the character state to idle, but that's interesting because if we are in the air when we lose and we go to that animation, we don't want to get reset to idle. Now there's probably actually a few things that you want to do in here and check for in here, but for now, since it hasn't caused any issues yet, we can simply add our if character state not equal to victory and character state not equal to defeat. That way, if we do run into this scenario, it is not going to override the character state to be idle. Now we have start crouch. We don't want to be able to crouch if we're in these states, so I'll add it to this if statement right here. And we don't want to stop crouching if we're in these states, so I'll add it right here as well. Alright, the basic attack. We don't want to be able to do that if we are in these states. Performing the recovery. This one is only possible if the character is not already in the recovery state, which is good. However, we don't want to be able to do this if we're in the victory or defeat states. So I am going to add it here as well. And we should probably add can move to this if statement as well, because if the character can't move, they shouldn't be able to perform the recovery. The grab. So we don't want to be able to grab opponents if we're in these states, so we can add them here. Start blocking. Don't want to be able to block if we're in these states, so I will add it here. Stop blocking. Stop blocking checks to see if we're in the E_blocking state, and so since it does a direct check for that, we don't have to add the other checks here. So this is perfectly safe. Start taunting. We don't want to be able to taunt if we're in the victory or defeat. So I'm going to go ahead and set that there. This is for losing life. We don't want to be able to lose a life while we're dead or respawning. That is true. We don't want to be able to do that. We also don't want to be able to do that if we are in our victory or defeat animations. So add that there. In exiting the revival platform. So we do check if we can move, and then we check if we're respawning or idle. This is safe because it's checking the direct states that we need to be in, and we won't be in any of those if we're in the victory or defeat, so we can skip this one. And there you go. That is everything in our logic that we need to check for to handle victory and defeat. Now I'd like to go back to the SSB template game mode and do one more thing. So for each player in this for loop, we do want them to not be able to move. So we'll set can move to be false, just to be completely clear about what that character can do once the round is over. So I don't care about the if statements necessarily. I just want all players. So players at index I, arrow can move equals false. And you'll see I wasn't able to use can move there. I can kind of force it, but it's not going to work because of the same reason the character state didn't work. See, it is inaccessible. And so this means we can go to our SSB template character.h, go down to where we made set character state, and I'm actually going to put it above it and say void set can move, and it's going to be a boolean called can move. Now we can go to the SSB template character. Let's go right above our set character state, void a SSB template character, colon, set can move, and this is a boolean can move. We're going to set can move equal to underscore can move. Then in the SSB template game mode, instead of trying to call the variable directly here and use that, we can say set can move, and instead of saying equals, we can pass in false. And now none of the players will have can move as true once the winner has been determined. Now I'm going to go ahead and launch the editor, and we will set up our animation blueprint states. The editor is back open, so let's go into the animation blueprint for our characters. And here is the AnimBP. So what I want to do is add two states today, the victory state and the defeat state. In this simple example, I'm only going to go from idle to those states, and they don't even have to return back to idle. At this point, the game is over, and we can keep them in the states until we change levels or whatever the case may be. So I want to right click and add a state, and I want to add one called victory and one called defeat. They have no events on them, they're nothing complex, very simple. Let's go into the victory state, and I have a victory animation. So this is the victory animation. The character is jumping up with excitement. We want to make sure that we don't set that to loop unless you want it to loop. You could absolutely set it to loop. So I'd turn it off, but you know what? I think I'm going to turn it on. Now let's set up our defeat state. So here's defeat. And same deal here. I had turned off loop animation, but actually I think we should loop it. I think it looks better that way. Now we have to be able to go from idle to victory and idle to defeat. And very simply, we can just check the character state, put them where they need to go. So idle to victory, if you drag that line, is this transition rule right here. We grab our character reference, which is the owner of the animation blueprint. We grab the character state variable off of it. We check equal enum if it's equal to victory. Then we drag the result into here. So if they are equal, this will return true, and that means we can take the transition rule from idle to victory. Now let's do the one from idle to defeat. And you can see it's the same thing. We have our character reference and our character state, but then we're checking for the defeat character state. And if they are equal, the character will return into the defeat state. So they will be defeated. And there you go, guys. That's all I got for you today. So thank you so much for watching. I really hope you enjoyed this episode, and if you did, please subscribe. It does more for myself and the channel than anything else you can do, and I just really appreciate it. I want to give a huge shout out to the YouTube membership, Discord supporters, and Patreon members. All you guys are fantastic, and I'm so grateful for you. Thank you so much. If you had any issues while watching this tutorial or any of my tutorials, feel free to join the Discord community. It is completely free. There's a link in the description, and I would be happy to help you. Anyway, guys, like I said, thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.